Hi everyone! Today I'd like to share a teaching aid I designed and 3D printed myself, a model of lens imaging that enables blind children to touch the paths of light. I'll walk through why I started the project, how I modeled it and printed it, and finally how to use it. Why I noticed this problem. This idea started while I was teaching physics to blind students. As you probably know, optics relies heavily on visual explanation, ray diagrams, image formation. These are things that are normally taught by drawing. But for blind students, verbal explanation alone makes it very hard for them to build a mental picture of light paths in space. So I looked online to see if there is a teaching aid specifically designed for blind children to understand optics through touch. I almost found nothing, so I decided to make it by myself. Modeling and printing. The whole model was designed through Fusion 360. I used a side view layout, a flat, elongated rectangular base plate with grooves cut into it, which hold the light ray rods and the optical elements in place. The optical elements attach to the base using small magnets, so students can easily attack, remove, and rearrange different light paths. After modeling, the next step was printing. I used a bamboo lab printer. One small detail in the printing, the lenses themselves are printed in PLA, which feels cool to touch, while the other parts, like the virtual image sections of the light rods, are printed in TPU, which feels soft. That way, blind students can tell a lens apart from other components by touch alone. Instructions for use. This is an all-in-one model. A single set of parts can be assembled into several different optical setups, including plane mirror imaging, convergence through a convex lens, divergence through a concave lens, lens imaging, and the rosetta ray through the optical center never changes direction, distinguishing the optical elements. The three types of optical elements are shaped differently, so they can be tell apart by touch. The convex lens is almond-shaped, the concave lens is apple core-shaped, and the plane length is just rectangular. As for the light ray rods, every light ray rod has an arrow on it showing the direction light travels. The rods also come into different textures. The smooth one represents an actual ray of light, and a threaded or repeated one represents the extension line of a virtual image. So just by filling the arrow and the texture, students can tell whether a given rod is a real light ray or the extension line of a virtual image. No need to see color or read a diagram. And it finally comes to the object and the image, the candle, in this setting. There is specific design for virtual images. A virtual image keeps the outline of the candle, but the inside is hollow or perforated. This way, students can feel the difference between something that's actually there and something that's only a virtual image. This teaching aid has already been open sourced and uploaded on the C3D platform. If you are a teacher or just curious, feel free to download it and print your own set. I hope this small tool can help more visually impaired children to understand optics through their hand. Thank you.